Hello, I'm Derek, and that's Felisia, and we're here today to talk about what not to do when building service brokers. So we both work at Pivotal, out of the London office and the service enablement team, and we build the on-demand service broker that powers the data service offerings such as MySQL and RabbitMQ that Pivotal provides. We've been building brokers for a while. I've been building brokers for almost 2 years now, and Felisia for almost a year. So hopefully we learn a thing or two that will save you a little bit of headache when you try to build your own. That's briefly the agenda that we're going to go today. We're going to talk about the Open Service Broker API spec and what it is. And then we're going to go through the broker operations. So what are the things that you need to implement when you are respecting the spec, when you're abiding to the spec. Then you're going to go to the main points of the talks, that like what you want to avoid and what you want to keep an eye on. And then hopefully we'll have some time for questions. So the Service Broker API spec, in general, like if you're building applications, your application will probably need some data, right? To do anything interesting, you probably need some data. There is a need, like Cloud Foundry, when Cloud Foundry was emerging as a platform, there was a need to bring first-class experience to the platform for services as well, not only for apps. And platforms like Cloud Foundry and Kubernetes both converged on the OSBAP spec, which is a specification that allows you to give the same service to both platforms. To provide the same service experience in both platforms, like the same lifecycle management experience, giving your developers a unified, structured way of consuming those services. So a little bit of history on the OSBAP spec. Around, like, as Cloud Foundry rose to prominence as a popular enterprise cloud platform, the foundation saw that they needed, like, software vendors wanted to bring their own services to the platform and want to provide their services, again, as a first-class experience to the platform users. So the foundation saw an opportunity there, and together with the community, they decided how the services, like, could interact with the platform. And in 2014, the output of that collaboration was the Cloud Foundry Service Broker API, which was around 2014 and defined the broker pattern for Cloud Foundry. Between 2014 and 2016, other platforms like Kubernetes emerged as like new abstractions that you want to run your apps and services on. The foundation saw the potential and an opportunity there to extend the Cloud Foundry Service Broker API specification to more services. And that's when the Open Service Broker API project was launched. To ensure that specification continued to be like relevant and used by different services, both platforms and service vendors, the foundation created a dedicated project committee to manage the OSBAP spec. Today it has members from Pivotal, IBM, Google, Microsoft, and others. So today, the Open Service Broker API spec is fully supported by both Kubernetes and Cloud Foundry, and you can find many services many brokers for the services. So, but what is exactly like a service broker? The service broker is this component that lives between the platform and the services. So it's, and what the OSBAP spec defines is a contract. It's what this component that we call the service broker or just the broker needs to implement in order to give to the platform an experience on services. And that gives like independent software vendors a simple and elegant way to deliver their services deliver service to applications. It also abstracts all the lifecycle concerns from the developer, so they don't need to worry about how do they manage, where do they want to deploy their MySQL, and let them focus on their own applications. So to develop a broker, you basically need to do three main type of operations. The first one is the service catalog operation, so that's defined in the OSBAP spec. And the catalog is what describes all the services that particular broker can provide. So, and also defines the plans. Plans, if you're not familiar with the plans is what determines what type of that particular service you want. So, for example, if you're deploying a MySQL broker, small plan might be a small disk size, and a big plan might be like a large disk size. And the only operation that it's like related to the catalog is the actual fetching of the catalog. One broker can also provide many services, so this is an array of services. The second type of operation is the instance management itself, which controls the life cycle of the service instance. And the operations there is like how do you provision and deprovision or create and destroy a service instance, and how you update one, an existing one. Finally, the third type is the actual access management, which controls who can communicate with the service instance. For the service broker perspective, this operation is called a binding. So a binding is giving an app or a user access to that particular service. And when you unbind, you revoke that access. So with that, I'll go to Felisia.
So as Derek said, we've been building brokers for a while now. And although the specification is quite straightforward, you can still fall into some pitfalls, and we'll show some of them today. So first of all, let's start talking about how your broker is running. By default, many times a broker can be running over HTTP, and the main problem here is the way CF communicates with the broker. So let's take the example of create service broker command, which will require the broker URL and the credentials. And those credentials are taken by CF and stored and encrypted in the database. However, the broker is still running over HTTP. And if there is something spoofing your broker, that connection might be not secured. So the simple solution for this is just to run your broker over HTTPS. And this means that CF will need to be provided with a certificate which is trusted, and the broker will need to be configured with that certificate. However, there is a little caveat that you need to be careful to understand where your connection where the connection to the broker will be coming from. So if there is a Go router in between your connection, the TLS communication will be terminated there, and then the rest of the communication from the Go router to the broker itself will need to be configured separately from your other certificate. So another issue with the way you're running the broker, it has to do with the availability of the broker. So by default, you can make the broker publicly available, and many examples of this are when you push the broker using the CF push command, and that's pretty valid because it's just an API server and will just have some endpoints. However, the things to consider in this case is that you might want to restrict the network access for your broker, and you will probably know pretty much who are the users of that broker, and it's pretty easy to restrict the access and to restrict where the broker can be communicated from. And if you're running it in CF, you can just implement the CF security groups, and you just put some rules around the protocols, the IPs that can connect to that broker. And with that, we can move on to the next issue, which has to do with the OSBAP spec. So it's really good that there is a spec and everyone can confirm to it, but sometimes, especially when you just start implementing it, you might partially implement the spec. And that's either because you don't need all the properties in each of the endpoints, or it's also because the spec, even though it's only 6 or 7 endpoints, it's quite long, it has a lot of little specifications. It takes 10 seconds to scroll through all this. So, first of all, why would you really need to implement the spec fully? And the first reason is for consistency. So you want any platform, that being CF or Kubernetes, to be able to communicate to your broker and not have any surprises. And on the other hand, you want to also future-proof your broker so that clients are always confirming. Clients that are calling your broker will be confirming to the spec, so you will need to be confirming to the same spec as well. For example, the v3 of the CF API will only have asynchronous calls to the broker, so if your broker is not serving async, it will have some surprises when you connect to the latest CF API. So with that, we have established that we want to keep implementing the entire spec, but that is also quite a difficult thing to do if you don't have all the infrastructure in place. And by that, what we mean is being able to check that you are always compliant to the spec. And the reason for that would be because you want to keep up to date with all the new features and provide the features that some other members of the community have already decided that are part of the next version of the spec. So for example, the version 2.15 of the spec will include the broker having ability to decide how long the max fueling duration is. Also, the broker can publish a version for each of the services, and the services plans can now specify whether they're updatable or not. And the way to keep up to date would be to either implementing one of the spec checkers that the community has already created, and you can just add them to your pipeline. And another easy way to just keep on top of the spec is by using some OSBAPI frameworks like the broker API or the open service broker client, which are already there, easy to use, and conform to the spec. Another issue with the OSBAPI spec is sometimes you go off spec, and that can be either by mistake because you didn't have the checkers on place, or it can be on purpose because there are features that for your purpose, for your broker would be beneficial, but they're not part of the spec. And in our case, for the broker that we create, we had to add a force delete flag when some service instances become completely unresponsive. And this is not part of the spec. It wouldn't really break our implementation of the OSBAPI, but still, it's not documented anywhere. So things to consider when going off spec is, do you actually really need to do it? You have to consider that there are already a lot of stuff on the specification, and you can go back there and talk to the community and see if there is a way to implement the feature that you need with what is already in the spec. And the second option is just join the conversation on the OSBAPI spec and OSBAPI call, or open an issue and try to see if there is a way that the thing that you're implementing might be beneficial to other people as well. However, there are a couple of issues with going off the spec, and one of them is the support from the platform is not guaranteed. So if you go off spec and you rely on a behavior that CF, for example, is providing today, there is no consistency and there is no assurance that it will actually work later on. And while doing this, you still have to make sure that you're remaining OSBAPI compliant and you're not breaking what is already there.
We're going to talk now about service bindings and how that can be a problem. So service binding, again, is that operation that gives access from an application, give access to a service. So you might be familiar with this diagram, but that basically explains how the cloud controller talks to the broker to actually create a service binding. So the user initiates the request with a CF bind service command that calls the broker, which will then communicate to the service to create a service binding. So for example, that might be creating a user on a MySQL cluster or something like that. The service will then return those credentials. The broker will get those credentials and return those credentials to the cloud controller on the VCAP services object, which will then be forwarded to Diego, which will then add that VCAP services to the application. So if you ever done anything like this, you know that if you run CFM or similar commands, you'll be able to see the plain text credentials there. So yes, and that's the problem, right? In general, you don't want plain text credentials over the internet. It's not a good thing. Especially when people can do things like that and, just copy and paste, send to their friends, jump in and try to debug themselves. Maybe something is going wrong. The main problems that comes with plain text credentials or plain text bindings, first is the leaking environment variables to logs. It's not unheard of that people log things like environment variables and like what is the configuration of their particular app or service when the application is starting. By having those credentials in plain text as environment variables, Because at the end of the day, that's what the VCAP services ends up being on your application, right? It's just an environment variable. You may increase the chances of people logging that. And then people don't treat logs in general with the same level of scrutiny and security that they treat their applications. So they might, send that to Papertrail or download it and email it to someone. So you run the risk of, you increase the risk of disclosure. Also, although the credentials are not traveling on the open internet, when you create a service binding, they should be inside the internal Cloud Foundry network. They're still transiting between components. And that also increases the risk of disclosure, right? You don't want that for similar reasons. And also, it makes rotating credentials slightly harder because if you cannot easily rotate the credentials, you might, stick with it for a little bit longer. And if you need to rotate, you need to either create a new binding or restage your app, and that can cause that can cause downtime and stuff like that. And people might avoid doing it in the first place, which again, if you have the same set of credentials for a long time, you increase the risk of disclosure. So one of the possible solutions for this problem is to use CredHub. For those that are not familiar with CredHub, CredHub is an open source credentials management system. It's a key value store. You store a value, you get a key, and then you can consume it. So it's made for credentials, so it encrypts your credentials and all of that. And it is supported on both CF and BOSH. So if you have a CredHub and CF can talk to your CredHub, the new create binding diagram might look something like this. So the create binding is still initiated by the user. It goes through the service broker the same way. It goes through the service the same way and create the credential. But then when the service broker gets the credentials back, it does something different. Instead of just sending it through on the VCAP services back to the cloud controller, it will actually store on CredHub. So this broker needs access to CredHub. And then it will store that there, and then it will give the application that the binding is being created access to that particular credential on CredHub. So it will get back from CredHub a reference, and then it will use that reference on VCAP services, sent back to the cloud controller. Cloud controller will then forward that VCAP service to Diego, and then the magic happens when Diego, if CF can talk to that same CredHub, when Diego is about to write that data on the app, it will resolve that for you. So you have access to the credentials in your app without having to do anything special on dealing with CredHub. So your credential, your binding, will look something like this instead of being a plain text credential, so slightly more secure. You cannot find where that service is running or anything like that, and if you send that in an email, it's not a problem. And you can find more about how to integrate CredHub on your Cloud Foundry deployment on that link. The next thing we want to talk about is multi-tenancy on service instances, and that's kind of our shameless plug. So let's think about how the broker actually processes commands, right? So if you have a RabbitMQ cluster, for example, what will create service do? Simple thing that it can do, it's just create a queue. So the cluster is running, you run CF create service, that creates a queue. When you do then run CF create binding, what that might do is create a user, not create bind service. That might create a user and give that user access to that particular queue, and that's it. It's simple, it's great, it's fast. When you delete the binding, what that will do, just delete the user. When you delete the queue, delete the service, that will just delete the queue. So your cluster will not change, it will be running, it will be there, and you are just changing how it interacts. And that definitely has some advantages, like it's quick, it's simple, easy to understand. But for some critical services and for some critical applications, that might come with some problems that you might not expect. One of the main problems is the Noisy Neighbour problem. So in the RabbitMQ specific case, the default behavior that it has is like after getting 50 KB of data in a queue, it will flush to the disk if no one is consuming. One anecdote that happened was someone created a service on a shared cluster, pushed an app that was producing things, so it was going to Twitter and getting tweets and putting in the queue, and then they forgot to push the consumer. So that queue was getting full, flush the disk, getting full, flush the disk, getting full, flush the disk, until eventually the disk got full. And then when that happened, all of their queues, all of their services that were attached to that particular cluster died. That was not cool. But that's not the only problem, right? So we also have some security problems. You have to think, are your bindings really unique? Because if you're creating user, can you ensure and guarantee, you have to think about it, can you guarantee that that user will not have access to a different queue or a different database? Do you need to think about escalation of privileges? Is that something that a user might do? Like if they get access to the cluster, can they just get access to the entire cluster? To a database, they can get access to the entire cluster. There's compliance as well. Some services, depending on the app that you're running, they just cannot share services, so this is really not a choice. And it's also cost, so you have to plan on how many service instances you want, and you need to plan that up front. So if you are running a MySQL offering, and you want, I don't know, you might deploy 3 MySQL clusters and never use them, like for 3 databases. So that is costing you money, and no one is actually using it. And you also need to manage and keep an eye on it. So if it's getting close to like the limit, you need to deploy more and all of that. Some alternatives of that particular problem. First, you can explore if you can limit the utilization of the resources. So things like MySQL and probably other services. You can implement quotas and that kind of stuff that will, at least for some of those problems, like the Noisy Neighbour, will stop them of actually throwing everything offline. It still can happen if like all the services are reaching the quota, then you might still be in a funny place, but you at least reduce the chances of that occurring. You can also consider service plans and how they impact the service instances. So do you need, a way of implementing quotas and still giving users some freedoms is to think about the plans and to think about what they mean. Are your plans too big? Maybe if you have like plans that are consuming all the memory, can you tweak it a little bit so more users can share that same resources? And finally, the best solution is to deploy your service on demand. What that means is instead of using an existing cluster or an existing deployment, every time that a user creates a service, that actually creates a new instance on your infrastructure. Of course, that comes with drawbacks. It's slightly slower, slightly harder to implement. It might be a little bit more difficult to start, but it can help you to like increase adoption of your services.
So in summary, some of the things that we have learned and we want you to think about are, consider if the way that you're running your broker, if you need to make it more secure, if you need to make it over HTTPS, and also try to conform as much as possible to the OSBAP spec and find ways how to keep on top of that and implement even the new features that come up. Secure bindings, secure service bindings, make sure that you don't use plain text credentials to return the bindings to the apps. And the fourth one is think about, do you need a multi-tenancy or an on-demand service instances? And actually the last one is think if your use case actually requires you to write an on-demand broker, because there are other ways, easier ways for you to just provide user-provided services, and you just add the credentials from another pre-provisioned service. In case that you want to start building a broker, you can start up with a broker API, which is available and open source to use. And if you want it on demand, you can start using the on-demand service broker. And with that, we can take any questions.
Okay, thank you.
Thank you.
And thanks for coming.